Uh, I'm Josh, the lead cadder's team to do the 6 Atom. I'm going to be showing how you could create a belt-driven chassis in Fusion 360. This isn't going to be a step-by-step tutorial. It's just going to be something to help kind of conceptualize how you do it. So there will be some things that will be missing. From if you actually built this, if you actually want to build this. But anyhow, first you're gonna want to start off with a basic side profile of your chassis. So you can start a sketch, make a rectangle, and enter the dimensions. Since a regular Mecanum from CodeBuilder is about 97 millimeters, I'm just going to make my width 80 and my length, say, 17 inches. Although you could adjust this, as much as you need. Okay, so now you have your side profile. Next, you're gonna click on the shape. Click on the sketcher right here, and press in your keyboard. What this is thing that you do is extrude your two-dimensional sketch and make it 3D. So usually, um, when we make chassis, we work with aluminum plates, and the width that we usually work with is 1/8 of an inch or 0.275 millimeters. I mean 3.75, which is why what I'm going to enter into here. Alright, so now that you have your two-dimensional object here, you're gonna want to start putting holes for axles and motors. Alright. Okay, so to find the center of your object over here, you want to draw a line across the diagonal. Although, I already started my sketch in the middle, so it already tells you the center. But if it didn't, that's what you would do. Now you want to draw another line, go to where the center of your wheel will be. So let's just say I'm going to come my wheel over here on 60, and then another line over here. Alright. Now, I'm going to put a hole for bearings so that we can put in our Mecanum wheels. Similarly, how you did at the beginning, you're going to press E, select A spaces, and now you're going to extrude them in the opposite direction. Make sure that it says cut over here. Alright, this may have bearing holes. So all these parts over here, they're from Go Build this website. So if you go there, you should see an option to download the CAD. So I'm going to redrag this into my file, and now I have a bearing. Alright. To man this bearing with a hole, basically what you're gonna do, you're gonna select this here on the left side of the screen, press M on your keyboard, which is a shortcut for move, select point to point on the right side of the screen, and then we're going to select this edge right here. This is basically going to make it so that you're moving your leg from the center of the object. Now you're also going to select this edge right here. And there you go, now it's perfectly aligned. From here, you could do that again. Actually, before you do this, I recommend breaking the link. What this will do is it will make it that if you alter the parent file, it will not change what you have in your document, which you don't really need to do now, but it might be helpful down the line. Or scenarios that you're just gonna do it again, it may help to hide this body first. This time, however, select Create Copy, since you need two. Alright. Snake heavy bearings. Oh, actually, I need to follow my own advice. I forgot. Select create copy. Alright. Say heavy two bearings. Alright. Next, you can create your holes for your motors. So normally, because if you're getting your belts from Builder, they offer specific sizes. So normally what you would do is you would check the sizes and how they match up with like the specific pulley that you're using because they have a calculator that allows you to calculate the bus sizes. Boy, I'm just trying to show you the concept of how you do things, so I'm not going to do that here. But there is what you would do to find out where you have to place your motors. But I'm just going to place them in a random position. Okay? It may be helpful if you first put the CAD of the motor into your document, which is what I'm gonna do. Uh, rotate that 90 degrees. And there you go. Alright. Okay, so after you figure out where you need to place your motors, you can draw a line from the center point of here to the correct distance. As I said earlier, I'm just going to put in the random value. So I'm on 20, that should work. Alright. And now I'm going to finish the sketch. Similar to how we did earlier, I'm going to break the link. And I'm going to use a point-to-point again. This time selecting this surface right here, even though it's an incomplete surface, even though it's an incomplete edge, Fusion 360 will see that it's a circle and it'll still select the middle point. And then I'm select this point over here. And there you go. Actually, alright. Something I think Fusion was coaching at the Soden Center probably, so if that happens to you, you can just select a full circle edge and it should be fine. The only problem now is that it's clipped into your side plate over here. So what I'm just gonna do, I'm gonna use the inspect feature to find the distance between these two pages. I'm going to click on the distance to copy it. I'm going to select the motor, free move, and then move it back for that distance. Oh god. You could use another point-to-point, but since the two motors will be pretty much aligned on the same, axes, I'm just gonna find the distance between these points. Points which will be the center points of the motors, and I'm going to copy the motor and move it that far. So I'm going to copy the create copy, and there we go. Oh god. So now that we had this, let's see how wide this motor is. So it's 37.5. Okay. Now that we no longer need to sketch and hide it, so earlier I mentioned the width for the motor, and normally with a bell-driven system, the motors are not going to be, the axles are going to be the only thing sticking out here because they're very short, and if you have wheels here, you could have the bell behind the wheel. That is something you could do, but I'm going to show you how to do it the other way with the belt on the other side of the wheel. So for this, the axle wouldn't actually reach. So normally, what you would do is you would have the motors stick out through the plate. And for that, you need to make a hole for the motors. So then, you take the diameter of your motors, and then we just reach rod this 120. We're going to take a diameter of your motors to 37.5. And you're going to add about a millimeter or so just for tolerances. So, +1. Copy that. And I'm not doing you. Alright. Okay, so you want to make sure you're not cutting your motors, so just hide those. So now. And there you go. Now you have full sphere motors. So what you could do now, for now you don't know how much you need to push your motors forward, so you can just keep them there for now, and it shouldn't be a problem. But now you can actually start putting in your axles and your mechanisms. So I'm going to take this axle. Okay, this axle is actually too short. So I'm going to retrieve a different one. Just give me a second. Alright, so now I'm going to put this file into the document. And just like we did before, I'm going to use a points point. Okay, Jimmy, you gotta edit this out, man. Still too short. Alright, so now that you have the shaft, you'll put it into the document, and just like we did before, orient it properly, and then use a point-to-point feature to align it with your bearing. You can select this curve over here, and move it right here to this bearing. And here we go. Now I'm just gonna go to break this link. These don't need to be sure. And I'm going to do that again. Like I said before, what you could do, since these are on the same plane, you could just find the distance between the two holes, which is 320. I want to create a copy of this and move it 320 millimeters. There we go. Alright. Okay, so Mecanum mules, they're hot-mounted, meaning that you need to make an additional piece, an additional kind of hub to get them attached to a hex axle. So you could use a lot of things for this, but I'm just going to opt for, well, hyper hub. I also forgot to mention, this isn't that important for you to be able to see the concept, boy. You should have this when you're actually building it. It's very important to have to experience to limit friction and wear on components. So because it's pretty quick, I'm just gonna add them in. All right. Now I'm going to put my Abraham into the tattoo. Just orient that properly. And here we go. So for the Abraham, you do have a curved surface somewhere here, which I'm going to try to use by considering that Fusion was having issues earlier. I think there might be a similar issue. But let me try. But yeah, alright. So in this case, just start a sketch on your piece of research. And you can see that the center is right here. So you can just keep that line over here. Select that as a written queen. And here we go. Now just repeat that process for the other side. And you're good. Now that you no longer need a sketch, you can either press V on your keyboard, or you can go down to the drop-down menu and do it manually. Okay. Now, now that you have this as spacers and a way to attach your Mecanum mills, you can finally put your Mecanum mills into the CAD. Like always, just orient that properly and move it out of the way. Okay. So for the Mecanum mills, it's actually pretty easy since you have these um you have these circular edges over here, and you have 1 years old, so select that. Select this as your origin point, and select this as your target point. I'm just gonna create a copy, so it'll make it easier. I just repeat that. And here you go. Alright. So now you had your Mecanum mills, and you pretty much know how much space you have. So at this point, you can actually put in your pulleys. Once again, to orient that, just do a point-to-point move. And select this round edge over here. Uh, uh, As I said earlier, you could do things differently. For example, have the pulley on this end instead of this side, which would allow you to keep your motors further in. Why, this is one way of doing it, and it's not really any less or more advantageous. Another thing is that here I'm using axle mounted pulleys. Why? If you use a hub mount, you could just have a spacer here and get up screws that go all the way through and attach both the Mecanum wheel and the pulley straight to the paper hub, whatever hub you use. But this does make it easier, so that is just how I'm showing you. Uh, just move that further in. Actually, and then put this on the satchels. Alright, so now you can select both of them and move them further in. As long as it's not getting in the way of these rollers over here, you don't have to worry about how much to put it in, unless you're trying. Like, unless you don't have a lot of space to work with, as in weight. But it shouldn't really be an issue. Alright. So now you can finally push in your motors. Now that you know where this position is going to be. And it's going to measure the distance between here and here to know exactly how much I should lift for. Alright, it's pulley 1.5 millimeters. And select both motors. And both them in fully 1.5. Okay. So at this point, I'll just create a copy of this and do the same thing for the motors. So, as I said earlier, you might need to adjust the distance between your motors um, and your wheel here and your pulley here. The reason being that if you're getting your butts from Cobuilder, they only accommodate certain bell sizes. So, well, you want to match that as closely as possible to get an effective transmission between the motor and the wheel. Alright. So now at this point, pretty much most of the bell drive is done. At this point, you just need to make a plate that helps you attach motors to this plate, and also another plate to connect the exposed chassis here. So first what I'm gonna do is just make the plate for the motors. This is very simple. All you need to do is make another rectangle that covers both the span of both motors. For example, like this. The measurements don't need to be exact, but I'm just going to do this. And then you secure that. When you do this, make sure that you have this selection. The short-term menu right here sets in your body seal heads on the current your motors. And once again, I'm going to make this 2.75 millimeters. 75 mm. Now I'm going to measure the distance to take here and more, and move it by that distance. Okay. You may notice that there are no holes here for melting, so what we're going to fix that is just go into here. I can start sketch and go in and make some holes. Now just extrude those out. And you have mounted holes now. I'm also just going to make some holes for the shaft. The straw diagonal line to find the center. And the size of the hole doesn't really matter because it just needs to accommodate for the size of the shaft. But if you want, you could put bearings. So I'm just going to make this 14 millimeters. And here you go. Now Tarsi gets this attached to the main plate. Normally you would have standoffs, so I don't have the particular length for this, but this is 37.75. And the distance of this is variable on the shaft, I would just move the source assembly so that it matches the size of standoff offered by the builder. In this case, I could just kind of do a demonstration of what that might look like. So I'll just show another rectangle. Once again, for this purpose, does not to be attacked. Boy. I'm gonna make 4 millimeter holes for the standoff. And, oh, actually, if you're doing it like this, it'd probably be a good idea to add holes in the middle as well, just for that extra bit of structural support. So I'm going to do that as well. Okay. So just extrude those holes. And as I said earlier, I don't have the specific length I'll need. Why, this is kind of what it would look like. Since standoffs are 6 millimeters, you just extrude it like that, and yeah. So pretty much you have a screw going in from this side and a screw going in from this side, and that's what would hold it together. Except instead of extruding it, you would, as we have earlier, you would just align it with the holes. I would just going to add all 6. It shares in your body. And there you go. And your pulleys. So pretty much the only thing left to do now is to attach a second plate. So for this, what you could do is you could. The easiest way to go about this is just to pretty much make a copy of your first one. So you're gonna select create copy, and move that to a point where we're happy with. So right here, anywhere that's out of the way of moved for it to. Since you don't need these holes over here, you can just select them and hit backspace on your keyboard, which should get rid of them. Yep. Alright. So you could leave it like this, but before doing anything else, I do recommend making holes, like triangles or something like that, to the middle way, because the outer plate really doesn't need to be that strong. If you cut it like this, you would really just be including unnecessary weight. Alright, so next you just want to do the same thing you did here with the standoffs. As I said earlier, I'm just going to make holes that could help you approximate what it will look like. I was going to make a cube, a square, rectangle. Help me see where to put the holes. Once again, I'm not being exact with it because I'm actually going to use this design, but you should try to keep your measurements exact. That's strange. Alright, I just, when you're doing this, make sure that, your shoot is set to either symmetric or two sides, but you want all to penetrate both. For some reason, soliding me to that, so I'm just going to redo the shoot. Now, once again, I'm just going to make the standoffs. Like I did here for the motors, it's definitely a good idea to have another two standoffs in the middle where I have nothing to do with, but you should definitely do that if you are able to. So at this point, you're pretty much done. All you need to do now is just some touch-ups, maybe add the holes, like I said. Um, add some fillets. Select all your sharp edges. Um, add some bearings on the outside or shear. Add some spacers if you want. And yeah, you should be good. Uh, thank you for watching. I hope this video helped, and good luck.